graphing common functions, we're going to talk about how we can shift, stretch, and compress functions. So last week we went over absolute value functions and linear functions. We're going to quickly review those before we touch on square root functions, quadratic functions, and cubic functions. Taking the paper you had last Thursday, please follow along with me. So when we look at the first four, these are all examples of absolute value functions. So the first thing we want to do is we want to focus in on the parent function, and that's what we're looking at in number 1. So at the same time, you're going to want to take out a blank piece of paper, and I'm going to create a table of values that represents coordinates to this function. So when I substitute in -2 for the x value, the absolute value of -2 is +2. When I substitute in -1, the absolute value of -1 is +1. 0 goes to 0. The absolute value of +1 is 1, and the absolute value of +2 is 2. Remember, absolute value is going to share with us what is the distance from the origin. Okay, so now that I have a table of values, I can quickly graph this. I'm going to go from the origin left 2 and up 2. From the origin, I'm going to go left 1 and up 1. Then I'm at the origin, going right 1 and up 1. And these are just directions. From the origin, go right 2 and up 2. And now we talked about using our ID to ensure that we have a precise, accurate graph. So the next 3 examples are going to work with the same basic function, but now we're going to be stretching it or compressing it, possibly reflecting across the x-axis, and then also shifting it left, right, up, and down. So horizontal and vertical shifts. So as we spoke about on Friday, if you happen to have a highlighter, take it out. If you don't, you'll be just fine. The first thing we're going to do is we're going to shift things. So if there is a horizontal shift and if there is a vertical shift, we're going to apply those first. From the origin, I'm going to shift my newfound origin to the left 1. It's always opposite of what you believe. Left 1 and down 3. So this lies to us and this tells us the truth. Bless you. Left 1 and down 3. This is my new origin. So everything we do now starts at this point. And I'm going to come up here if you were gone on Thursday or didn't understand the lesson. I'm actually going to cross out those 2 pieces. The next thing I have to do is I have this value out front that is stuck to the absolute value, and so how that's going to impact it, it's going to impact it on how fast it rises. This value out front needs to be multiplied by the y's. So 2 times 2 is 4, 2 times 1 is 2. I'm going to multiply each of these times 2, and now when I actually go ahead and graph this, this is my new origin. From here, I'm at 0, 0. I'm at 0, 0, so I've taken care of this piece. Then I'm going to go to the right 1 and up 2. Right 1 and up 2. Come back to the origin. From this new origin, I'm going to go right 2 and up 4. Right 2 and up 4. I'm going to go back here, and from the origin, I'm going to go left 1 and up 2. Left 1, up 2, and finally, from the new origin, left 2 and up 4. Using your ID, connecting 3 points to the left, 3 points to the right, we have our new function. So if I compare it to the parent function, I have shifted it horizontally to the left 1. I've shifted vertically down 3. That's my new origin. And then we can see it rises at a faster pace. It's 2 times it, so it's by a factor of 2, vertically stretched by a factor of 2. In example number 3, I'm going to start by finding this newfound origin. I'm going to go to the right 2 and up 1. Right 2, up 1, and this is my new origin. Okay, now just like I impacted the rise here, and we say this stretched, vertically stretched by a factor of 2, well, I'm now going to impact the rise again, but instead of being stretched or rising faster, it's going to rise at a slower pace. We say it's vertically compressed or flattened out. Each one of these is going to be multiplied by 1/2, always the y's. 2 times 1/2 is 1. 1 times 1/2 is 1/2. 0 times 1/2, 1 times 1/2, and 2 times 1/2. From my new origin, I'm going to go to the left 2 and up 1. Left 1, up 1/2. Right 1, up 1/2. Right 2, up 1. And we we see, if we compare it back to the parent function, how it rises at a slower pace. In fact, it's vertically compressed by a factor of 1/2. Okay, on to my last one. There is no horizontal movement on the inside, but I am going to go up 4 to find my new origin. So I've taken care of these pieces, and I have a hidden -1 out front. So each one of these y is going to be multiplied by a -1. So from this new origin, I'm going to go left 2 and down 2. Left 1 and down 1. Here's 0, 0, right 1 and down 1, and right 2, down 2. So to recap the learning from last Thursday, that was the day before we had the I day, or the teaching and learning day. We went over absolute values. We've reviewed 4 of those type of problems, and we went over linear functions. We're also going to review at this time linear functions. So just like I made a table of value for absolute, I'm going to cross this out right now, and I'm going to make a table of value that's reflective of the input and output values that correspond to this basic function. So if I input -2, the output is also -2. We can see that the x and y have to equal each other. So -1 equals -1, 0, 0, 1, 1, and 2, 2. Very simple. We're going to come over here and graph those. Here's my 0, 0, 1, 1, 2, 2, -1, -1, and -2, -2. Now, how do we actually translate that? Excuse me. So in this position, it says we're going to have a new origin. The origin is going to be found by moving to the right 1 and up 4. So on your graph, make a little mark at +1, +4. +1, +4. So find that ordered pair. So I'm going to go to the right 1, just opposite of what you think, and up 4. This is my new origin. From that, I apply this exact same thing. So this is the new origin. This is 0, 0. Then I'm going to go over 1 and up 1, to the right 1, up 1, to the right 2, and up 2. And I'm going to do the same thing going the opposite direction. Left 1, down 1, and left 2, down 2. Looks like it. So let's locate this new origin. I'm going to go from here, I'm going to go left 2 and down 1. Left 2, down 1. This is my new origin, and I'm following this pattern. So this is my new origin. I'm going to go right 1, up 1, right 1, up 1, right 2, up 2. From my new origin, right 2, up 2. From my new origin, I'm going to go left 1 and down 1, and left 2, down 2. Excuse me. Okay, now this throws us off. A lot of times we see it in back, but it can also be in front. No, it's not attached to the parentheses. So I'm going to go left 1 and up 3. Left 1 and up 3. And then I'm following the exact same pattern. This is my 0, 0. I'm going right 1, up 1. Right 2, up 2. Left 1, down 1. And left 2, down 2. Moving on right now to square root functions. You've definitely seen square root functions before. I'm not sure if you've graphed them where we include the translations where we're moving it left to right, we're stretching it, we're compressing it, or possibly even reflecting across the x-axis. So we're on right now to our third type of function we're going to review today. So I'm going to take this paper and let's come up with the parent function initially. Now let's go back to what we remember learning about domains. So remember, we had a couple different things we have to remember with domains. First one is if we have a variable in the denominator, remember the denominator can never equal 0. The second involved radicals. One time a radical was in the numerator and one time was in the denominator. In both cases, the nth root had to be even in order for this to matter. So when you don't see a value out front, it is a hidden 2. We know 2 is even. So what were the rules here? Rules here is that n had to be greater than or equal to 0, the value inside, and here n had to be just simply greater than 0. Because remember, in the denominator, we can never have it equal to 0. We're going to apply this second rule to what I'm doing right now. We can see that I have a radical. I don't see the nth root, so it's a hidden 2, which is even, which means I know the value inside has to be greater than or equal to 0. So how does that matter when I'm plugging in values? This is talking about the input values, or the x's. The x's have to be greater than or equal to 0. So let's start with 0. That's the smallest number I can plug in. The square root of 0 is 0. Now, we definitely could do the square root of 1. The square root of 1 is 1. We know that. But I'm not going to write down 2 and 3. It doesn't mean they don't exist, but the output, or the answer I achieve when I use a calculator, is an ugly irrational number. So let's stick with perfect squares. If I go 4, the square root of 4 is 2. I'm not going to do 5, 6, 7, 8. They're ugly. If I do 9, the square root of 9 is 3. Now, we don't have large graphs, but 16 would go with 4, 25 would go with 5, and so on. This is the parent function for a basic square root. So let's go ahead and let's graph this. 0, 0. This says go over 1 to the right and up 1. Over 1 to the right and up 1. From the origin, go right 4 and up 2. Right 4 and up 2. And I don't think we can go all the way up to 9, but let's check. 4, 5, 6, 7, 8, 9, and up 3. We get the basic idea here. And there's my square root function. It's like this arch. The same concept we applied with linear functions and absolute. We're going to do the exact same, and the same rules apply. So in here, I'm going to find my new origin. I'm going to go to the left 1 and down 2. Left 1, down 2. So from here, I'm going to go left 1 and down 2. This is my marking. And I'm going to go back to this position. This is my 0, 0. So here's my 0, 0, then I'm going over 1 and up 1. From my new origin, I'm going to go over 4, 1, 2, 3, 4, and up 2. And lastly, over 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 3. It's going to be stretched vertically by a factor of 3. Stretched vertically by a factor of 3. Let's go on to the next one. There's no number inside, so I'm not going to shift this to the left or to the right. I am going to go straight up 3. And now I have a number in front, and this value is a negative 1 that's in front. So I have to come back here and multiply the y's by negative 1. 0, negative 1, negative 2, and negative 3. This is my new origin. So 0, 0, then I'm going to go right 1, down 1, right 1, down 1, right 4, 1, 2, 3, 4, and down 2, 1, 2, and right 9 and down 3 would be way out here. Alright, so in this case, we've reflected it across the x-axis and shifted vertically up 3. Quadratics that you learned about in 8th and 9th grade. So quadratic functions, let's look at the parent function for quadratics. Do me a favor, make your little t-chart. There's no limitations to what we can plug in. And remember, when we square everything, it's going to make a positive. So negative 2 squared is positive 4. Negative 1 squared is positive 1, 0, 0, 1, 1, and 2, 4. So that is my chart. Let's go ahead and let's graph this. So here's my 0, 0. I'm going to go to the right 1 and up 1. Going back to the origin, right 2 and up 4. Back to the origin, left 1, up 1. Back to the origin, left 2 and up 4. So it's looking just like this. Now we're going to make predictions without doing any graphing to start with. So let's look at these. I'm going to shift this which direction? Left, right, up, or down? Take a guess. What do you think? turn to your tutor. Which way do you think you're going to shift this? Based on what we've done for the other functions. To the right 3, it's lying to us, to the right 3. We're not going up or down, I'm simply going to go to the right 3. So everybody go to the right 3, make your little new origin mark, and then I'm just going to apply this. So this is my 0, 0. I'm going to go right 1, up 1, go back to the origin, right 2, up 4, back to the origin, left 1, up 1, and back to the origin, left 2, and up 4. Horizontally, it lies to me, it tells the truth for the left 1 and down 3. And this is going to be my new origin. There's no number outside other than a 1, so multiplying by 1 doesn't change any of the y. So this is my origin, 0, 0. Right 1, up 1. Right 2, up 4. Left 1, up 1. Left 2, up 4. Okay, now for this one right here, for this one, I'm going to go ahead and I'm going to shift to the right 2 and up 1. Right 2 and up 1. That is my origin. Right 2 and up 1. Lies to me, tells me the truth. Then I now have a number out front that's different than 1, which means that we're going to impact how fast this parabola rises. So it's going to be vertically stretched by a factor of 2. So each one of these is going to be multiplied by 2. 8, 2, 0, 2, and 8. Always multiplying the y's by the value up front. So here's my 0, 0. I'm going to go right 1 and up 2. Right 1, up 2. Right 2 and up 8. 2, 4, 6, 8. Left 1, up 2. Left 1, up 2. Left 2, up 8. And we can see the shape of it. It's still the same basic shape, but what we've done is it's rising faster, or it's stretched vertically by a factor of 2. Cubic functions are probably brand new for you. So now we're going to go degree 3. So cubic functions have an exponent that is the third. That's the highest exponent on a variable. So the first thing that we've done with everything else is we're going to make a table of values that's going to reflect the parent function, which I have right here. So this is my function. I have x and I have y. There's no limit what I can plug in for the inputs. So I can plug in negatives, I can plug in positives. Let's do -2. So -2 times -2 times -2. Well, if you take a negative times itself 3 times, an odd number of negatives produces a negative. 2 times 2 is 4. 4 times 2 is 8. If I do -1 times -1 times -1, again, an odd number of negatives produces an output that's negative. 1 times 1 times 1 is -1. 0 cubed is 0. 1 times 1 times 1 is 1, and 2 times 2 times 2 is 8. This is my basic table that I'm going to use for cubics. Everything else is exactly the same. So I'm going to go ahead and graph this. Let's find 0, 0. Then I'm going to go right 1, up 1. Right 2, up 8. Right 2, up 8. Over 2, 2, 4, 6, 8. And then I'm going to go left 1, down 1. And left 2, down 8. Okay, so in this position, this says lies to you and tells you the truth. So you're going to go to the right, left 2, and down 1. Left 2, down 1, and that is your new origin. Since there's no number out front, we don't need to multiply it by any of the y values. I'm just using this as a guide, a pattern. So this is your origin right here. From here, I'm going to go right 1, up 1. Right 1, up 1. Right 2, up 8. Right 2, up 8. 2, 4, 6, 8. And now I'm going to go to the left. So from my new origin, I'm going to go left 1, down 1. And left 2, down 8.